So we have disaggregation for the RAN as a CRAN implementation. So it's a horizontal centralized unit, remote unit disaggregation. And we have the centralized unit disaggregated into a network function, which resides along with the EPC network function instances on the cord. Actually, in addition, we have an SD-RAN solution where the access node, the base stations themselves, are programmable, and the programmability comes through ONOS. So just like CORD, XOS is the services operating system for MCORD. And these services are either managed by network functions managed by OpenStack, or actually flow management functions that are controlled by ONOS. And in MCORD, we have both. So the basic connectivity requires a RAN as well as EPC. So we have RAN as a service and EPC as a service for starters. But depending on the use case that you can think of, we also have different flavors of EPC and RAN that we can onboard and use. And in that light, one of the important pillars in 5G is network slicing. So we have that implemented. But in this instance, imagine realizing the entire EPC, the disaggregated EPC, as a suite of VNFs. And our centralized unit for the RAN is also realized as a VNF. But on top of that, to allow for the SDNization of the RAN, we have an ONOS control for both the centralized unit and the remote unit. So now let's focus on the RAN aspect within MCORD. So at the Mobile World Congress in Barcelona in February, we made an announcement. ONLab and xran.org started to work together closely towards coming up with a unified solution for the mobile operators, which includes an SDN RAN as part of the complete offering. So what XRAN intends to do is to come up with an extensible SD-RAN solution where the different network functions that reside within the protocol stack in an eNode B are actually configurable, programmable, or invocable externally by an SDN controller. And in our solution, that SDN controller is clearly ONOS. So you can imagine, for example, the ONOS configuring the handoff parameters, or actually invoking a handoff operation for a given user based on a local policy plus optimization that is done at the SDN controller. So let's also start talking about network slicing in this concept. Network slicing, as I mentioned, is one of the fundamental topics within 5G. So as far as 3GPP is concerned, network slicing is a virtual network that is created for a specific market scenario. And that virtualized network has associated resources allocated to it and the corresponding network functions that are used to govern these resources. Using this definition, now let's talk about how to slice the RAN. Within the RAN, our resources are wireless resource blocks. So for a given RAN slice, we have to programmatically allocate some of the resource blocks to a given slice. That allocation could be static or dynamic based on the use case that we want to aim for. And attached to those resource blocks, we have the RAN side network functions that we can describe for that RAN slice. Namely, we have a scheduler that is governing these resource blocks, as well as the handoff parameters, the admission control, and link aggregation policies. And by the way, when you think about it, in the RAN, you clearly have a bidirectional communication. So whatever I say here applies independently for both the uplink and the downlink. So this solution that we have at MCORD, which, by the way, has been agreed to be incorporated into XRAN, so that we will have a unified RAN solution which incorporates the XRAN APIs and will integrate our RAN slicing solution and provide the necessary APIs within the XRAN framework. So the operation then will simply be the ONOS XRAN will send configuration commands to a local agent inside either a standalone eNode B or a CRAN solution. And that local control agent inside the eNode B will distribute this command across the appropriate network functions within the stack to actually create the slice. For the CRAN solution, it is more or less the same. The only different part is the ONOS XRAN application or controller will communicate with the centralized unit directly, and the centralized unit will have a local control agent which will abstract this information and forward it on to the relevant remote units to complete the slicing creation. Okay, so let's now spend some time on the EPC. Within MCORD, we have a number of EPC offerings. So our collaborators and partners have contributed their EPCs. And one solution is a full CUPS compliant, fully disaggregated EPC that is closed source. Another solution we have is an open source one. And that one has a Release 8 EPC offering with a simplified HSS that resides inside the MME. A third solution that we have is also an open source solution that is currently being still worked on. And that one has a very scalable data path, user plane, and the corresponding control plane partially is actually realized on ONOS, but the separate HSS and MME components are being finalized as we speak. So we talked about RAN slicing. Now, for the core network, we actually have the capability to do core network slicing as well. And in the MCORD solution, the base station serves as an anchor point so that programmatically a base station can forward on a flow basis a specific flow to a specific EPC instance, thereby creating network slicing. So that automatically allows us to stitch a corresponding RAN slice to a core network slice for an end-to-end programmable network slicing solution. Okay, so Guru in the morning talked about innovation pipeline, and MCORD is truly an innovation pipeline for 5G. We have an open source CORD platform on which we built MCORD, and we have different flavors of open source EPC and a fully programmable RAN. And the combination allows for rapid innovation on the path towards 5G. So if I were to give a couple of examples of what we have accomplished so far, is we have already realized a fully CUPS compliant EPC. We have realized disaggregation of the EPC. And when I say disaggregation, it's not just the disaggregation of the EPC components. We have also gone into the work towards disaggregating the MME into mobility management and session management components. So for the RAN, we are slicing the wireless resources. So you can imagine almost creating a virtual base station, which has a smaller set of resource blocks allocated to it, but that allocation could be static or dynamic, like I said. And for those resources, you have an associated scheduler, an associated set of handoff parameters, link aggregation policy, admission control, unique to that slice. So if on a base station you have multiple slices, you have, that means you are compartmentalizing the resource blocks into non-overlapping groups, and for each group, you have the associated suite of functions.
So you're also allocating computing power like VMs, or is it
that is, the eNode B itself, if it is a standalone eNode B, it works on more specialized hardware and not really x86-based servers. So when that is the case, no, it really depends on how that hardware is constructed. But if you have a CRAN solution, at least on the CU part, the centralized unit portion, that is managed by CORD.
Multiple carrier?
That is definitely one use case. You can have a shared RAN or a neutral host solution, but at the same time, for a single operator, you can, this way, depending on your use case, create vertical silos for different operations. If you want, for example, to create a silo for multimedia traffic so that you can have a multimedia optimized scheduler governing those flows and put an upper cap on the capacity that multimedia traffic should have on a base station, you can do that. So depending on different use cases, RAN slicing can be used. Yes?
So a similar RAN slicing thing based on the first person's question is something like semi-persistent scheduler, what you use for VoLTE, right? Like where you try to like dedicate a few static like resources just to minimize the latency of VoLTE traffic. Do you envision some similar RAN slicing techniques for VR, AR, or do you see like you can use some of the current RAN slicing techniques to next-gen applications like VR, AR?
You can probably treat, with today's networks, AR, VR, with semi-persistent scheduling, and hope to get some of the...
But the packets are small for semi-persistent scheduler, right?
Exactly. I was just going to say that that actually has some drawback in terms of the video encoding and the associated packet division. So a RAN slicing solution like the one that I was talking about would be a lot more suitable for that. Yes?
last question. So in order to achieve the end-to-end slicing, and I'm going to go back to what we discussed a couple of weeks ago, there needs to be some sort of pairing between RAN slicing and the core network slicing,
Yes.
right? And so I have two questions. One is if you can, maybe for the benefit of the audience, give a little bit more insight how this is negotiated and whether this is done with ONOS or is it depend on ONOS. And the second question is, can I run, if I do this end-to-end slicing, can I have like two different VPC instances running, maybe it's different vendors or different systems, and then do the slicing also. It could be like, also multiple RAN vendors on the other side, if you can shed some insight on that.
Sure.
Thank you.
So basically, when we talk about end-to-end network slicing, we're talking about a policy, an operator-based policy. So that policy will include the details of the RAN slice and its corresponding EPC instance that it needs to connect itself to. So for the case of LTE, all you have to do actually is tie a given RAN slice to a specific MME, and it will be the MME that constructs the entire EPC connectivity within LTE. So you can think of for example, think of an end-to-end slice policy that says IoT devices, and in this in the San Ramon area, IoT devices, I create a slice that will have a dynamic allocation of a maximum of, let's say, 5% of my resources, and it will use round-robin scheduling. No handoffs are allowed, etc. And then you will be able to say, oh, all of these flows will be forwarded to the EPC with this specific MME. So that's how you will actually programmatically do that. And in real time, if you want to change that policy and forward that to a different EPC, then you can edit that using ONOS. And these policies are pushed down to the local CU and RU units via ONOS.
So this is essentially it's the CORD or SDN controller essentially that will push down this policy.
Yes, yes.
So we can foresee a scenario we can have like a 5G RAN talking to a 4G EPC and vice versa.
Yes.
It could be a 4G RAN.
Yes. Yes, yes. And we already have actually a solution where EPCs from different vendors can coexist in a multi-slice scenario. We have that already.
So I think we're out of time for questions right now.
Thank you so
thank you.
much.